Okay, for the 45, 45, 90 triangle in a unit circle, we have to learn what the sides are for it. The first one you come to is right there, where this reference angle is 45 degrees. We make our triangle straight down to the x-axis. This here is a 45 also. And we know that the radius we just drew is 1. So trying to recall your geometry day rules for a 45, 45, 90, you learned that a basic 45, 45, 90, I'm just going to make one up here, let's say that leg was 6, this leg here was also 6. That just means that this leg here and this leg here will be the same once we find them. If you go back to this triangle here, to get to the hypotenuse, you had to multiply by the square root of 2. And that's what you did in geometry. So now we have to recall that when you were given the hypotenuse, which is what that is, I'm going to make up a number here, let's say 4. To get back to the leg, you would divide by the square root of 2. And that would end up looking like this. But somewhere along the line you had somebody tell you that a square root in the denominator is frowned upon, so let's try to recall the process to make that legal. You would multiply this fraction by a fancy form of 1, and the fancy form of 1 you should choose is root 2 over root 2, and that's going to get rid of the radical symbol in the bottom, in the denominator. On top you have 4 root 2. On the bottom you have 2, because that's just square root of 4, which would simplify to 2 root 2. So you did that in geometry. For this triangle, the only 45, 45 we'll use in our unit circle, the hypotenuse is a 1. So to get back to the leg, you would divide by the square root of 2, just like we did on this random problem. 1 divided by square root of 2, if it's considered illegal, to make it legal, we multiply by root 2 over root 2, and you would get on top here root 2 divided by root 4, but that's just 2. So that's it. This root 2 over 2 are the legs of a 45, 45, 90. So that guy, store in your brain, memorize that, that's crucial. So what does that mean? Well, let's use it. A 45-degree angle located here looks like that. If we were in degrees, cosine of 45 is equal to the adjacent side over the hypotenuse, in this case root 2 over 2 divided by 1 is just root 2. That's simple. Sine is the y value. The y value is this up and down side. Root 2 over 2 is the same. It's also root 2 over 2. Now, we are not going to have degrees, just like you don't have degrees on the ditto that's in front of you, so we need to figure out 45 degrees is what in terms of radians. So we come back over here and we recall that straight left is pi, and pi is equivalent to 180 degrees. So 45 degrees is what fraction of 180? 45 is what to 180? And you'd end up getting 1/4. So every 45 degrees is 1/4, meaning this angle we drew here is pi over 4. So what you see on your paper here, the 45 degrees, if I changed them to radians, would be that, and they're both root 2 over 2. So when you see a 4 in the denominator, we're going to know that that came from a 45-45 right triangle in our unit circle. So let's talk about the other ones that go around the circle. The one that's over here in quadrant 2, that is 45 degrees away from pi is 3 pi over 4. Now hopefully that makes sense, because pi, if you think of it in terms of fourths, is 4 over 4. So the one right before it would be 3 over 4. This one would be halfway between those, is 2 over 4, but we don't ever write 2 over 4. We already know that that's pi over 2, or 1/2 pi, which is here. So 4 over 4 is straight left at pi. The one that's down here in quadrant 3 would then be 5 over 4 pi. Here would be 6 over 4, which we don't write a triangle for that location. This one over here would be 7 over 4. And if you got all the way back around again, you would be at 8 over 4. But we already know 8 over 4 is the same as 2, and this is the location of 2 pi. So all of the 4's are the denominators for a 45, 45, 90. So let's try one now. If I did cosine of 3 pi over 4, I would hope that you would draw your unit circle if it wasn't given to you. Label straight left. Straight left we know is pi. I would like you to put the fraction that's equivalent to the number 1 using a 4, meaning 4 over 4. So once you know where 4 over 4 is, you can best guess where 3 over 4 would be, which would be in the quadrant right before it. Make your angle, drop your triangle, put 45 as your reference angle because of that 4. The nice thing is, when you recognize it's a 45, 45, 90, you know that both legs are the root 2 over 2. Now you just have to figure out whether it's positive or negative. Cosine is the x value, and the x value of this coordinate point right here is what you went to the left. And going to the left is negative, so the answer to this guy is negative square root of 2 over 2. If I would have asked for sine at 3 pi over 4, you would have given me the y value. The y value is the up or down fella here. It's root 2 over 2. It's going up, and going up is a positive direction. So positive root 2 over 2 is your answer for that one. Hopefully that's enough, because we've done 2 of the 4. There's only 4 possible 45, 45, 90s that I can give you. The other 2 are down here. They should still be on your ditto for you to try to complete. And if you need more help with the others, I'm going to do another ditto, or probably another video you can watch just to review the 30, 60, 90 and the other locations for special right triangles. So, hope you had a good weekend. See you soon.